Any discussion of planetary systems in our universe has to begin with our own planetary system, the solar system. 4.6 billion years ago, in the local interstellar cloud, in the local bubble, in the Milky Way, our solar system was formed due to the gravitational collapse of a giant interstellar molecular cloud. 8 planets, 1 star, dwarf planets, an asteroid belt, comets, meteoroids, and moons. These are the objects that make up our solar system and are the basis of any fully formed planetary system, really. Younger planetary systems would have planetesimals and circumstellar disks, however, since planets are still forming around the host star in an accretion disk known as the circumstellar disk. At the time of recording, there are 5,389 planets and 3,980 planetary systems, and there are 859 multi-planet systems. So, given this brief introduction, what kind of planetary systems are out there? When answering a question like that, we need a pretty big caveat. There are an estimated minimum of 100 billion planets in our solar system, and we've only discovered roughly 5,000. So talking about this involves a tiny number of observations, relatively speaking, and a hefty amount of speculation. But I'm going to try and stick to just observations we've made so far. In general, a planetary system is a set of gravitationally bound non-stellar objects in orbit around a star or star system, where a star system is just more than one star gravitationally bound to each other, so a binary star, for example. And then you have the planet orbiting one or both of those stars, or more accurately, I guess, the center of mass of the whole system. You need at least one planet and one star to constitute a planetary system, although just like our solar system, such systems may also consist of multiple planets, comets, asteroids, dwarf planets, more than one star, etc., etc. There are some downright unusual planetary systems that have been discovered, but I'll go through 3 of the most interesting planetary systems in my opinion. Found by Dr. Niall Deacon in 2019, an exoplanet known as 2-mass J2126 between 11.6 and 15 Jupiter masses was found. This is likely either an extremely large gas planet or a brown dwarf. This isn't exactly what makes it interesting, however. 2-mass J2126 is 1 trillion kilometers from its host star, or about 7,000 times the distance from the Earth to the Sun. It's so far from its host star that it takes around 900,000 Earth years to orbit its star, compared to our 1 year, of course. An explanation for a planet at such a distance from its host star is actually currently unknown. Seeing that planets and their host star formed in the same molecular cloud together, it's quite unlikely that this planetary system was formed in the same way as a normal planetary system. However, we don't know for sure. Next, we have a terrestrial, aka rocky planet known as K2137b. Its mass is around half that of Jupiter, and it only takes around 4.3 hours to complete 1 orbit of its star. It has the second shortest orbital period of any known planet. This planet is far too close to its star to expect to find anything of note on it, even if you could get there. And by anything of note, I mean life or liquid water. It'll be heavily bombarded with radiation, it'll probably be way too hot, and yeah, it's dead. In general, it's actually much easier to find planets that are very close to their host star. This is due to the way that they're detected. Exoplanets are commonly found through a method known as a transit method. When a planet crosses the face of its host star as it completes an orbit, it blocks some of the star's light. And the closer a planet is to the star, the more light is blocked, making it easier to detect. Lastly, this one might surprise you, but one of the weirder planetary systems that we know of is our own solar system. And not just because we have life in it. The most obvious starting point is looking at the amount of stars. Our solar system has 1 star, but most stellar systems actually have more than 1. 2, 3, 4, or even more. So that's already one reason why we're quite unusual. We also have quite a lot of planets in our solar system. Only 1% of observed planetary systems have 8 planets or more, and we have 8 planets, so we're in the 1% of planetary systems detected that has that amount. We could also talk about the Kuiper belt where Pluto's orbit lies. This belt is a region of small icy bodies beyond Neptune, and a belt of objects like this isn't commonly observed in other planetary systems. Neither is actually an asteroid belt such as the one between Mars and Jupiter. This is probably just due to our observational capabilities. It could turn out that they are a lot more common than we thought. However, as far as observations go, we haven't seen much of them. Even having a planet with liquid water on its surface like Earth is very unusual. We haven't discovered any body with liquid water on its surface in the universe. There's obviously a caveat, which is we haven't seen many bodies, and there probably are astronomical objects out there with water on their surface, but we haven't seen any. Liquid water on their surface. Even something like the stability of the planets in our solar system is quite remarkable, given the amount of planets we have and how stable they've been for such a long amount of time. So there are a lot of unique things about our solar system. I'm sure even if you dive deeper into it, you can find many more reasons. And if you're interested in reading about the planets and stellar systems and planetary systems, I have references to what I'm talking about in the description below. I have my Twitter, website, and my TikTok in the description. So feel free to click those, ask me any questions, etc., etc. And I guess I'll see you next week for another episode of me talking about astrophysics.